So let's discuss what is file input output in Scala or file handling in Scala. So basically file handling or file input output handling is something when we want to write something in a file from our program, or we want to read something from a file into our program. So this is somehow we are going to manage with this file handling. So Scala would not provide you any such support for file handling, but the good thing is with Scala we can use Java input output libraries, okay, which would provide us to use, create, open, read and write operations, because we have some print writer classes or file class we have, so that we can use those classes from Java and Scala as well. So I'll discuss this code in the respective IDE I have. So as you can see, this is the simple object we have created. We are creating a new variable named file object, which is the object of file. So this file class would take the argument over here with path or without path of a file. So we are trying to create a abc.txt file. If the compiler would execute this statement, then it would create an empty abc.txt file. In the present directory we have this program, okay. Then this file object will be passed into the print writer class, okay. We are trying to create an object of print writer class, which would expect to pass an object of a file, okay. Then why we are doing so? Because print writer later can call write method, where we can write from our program into a file. Which file? This file. So if I simply execute this program, let me execute this file input output. It is not showing anything, it is terminated. But if I simply refresh it, because it would create a new file, okay. So if I refresh this directory, it would create a abc.txt file over here. So if you don't want to create a file over here, this is the by default workspace. You can provide the path using slash over there, and you can create a file in a specific folder as well. So if I simply open it, what would be there inside this file is this statement, because we have returned this statement using the write method of print writer, and print writer is actually the object of print writer class. So from that class we are using this functionality of writing it, okay. So there is a reading functionality as well, so you can explore this by yourself. If I simply open it, it would contain that message. So this is very simple. Actually this is not a concept of a Scala, but as you know, Scala would also run on the same JVM as Java would run, so it would provide you some functionality of Java as well. It is very close to Java as well, okay. So you can directly use, as you can see, we are not using these libraries from Scala, because Scala would not provide you such libraries. We are using the file and the print writer or IO library from Java, okay. That is what we have written, okay, over here. So this is very simple input output operation in Scala. The next topic we are supposed to cover in this video is type classes. I think it is too much theory, so first let's discuss the code, so it would be very easy for us to understand what we have written over here. So let me discuss this. First you just need to focus over here. This highlighted part, it is a trait with name show, and we are passing this generic. T as a generic we are passing, and we don't know what type this T means. It can be integer, it can be string, but we know one thing, that after the execution of this function it would return a string, okay. Input can be anything, but it would return a string somehow. That is what we have mentioned. This is only the declaration in the trait. So if we try to implement it or extend this trait, we should provide the definition of show method, okay. So but it is not specific. It here T can be integer, or T can be string, or any other data type. So that's why this trait is little generic. Okay, let's try to implement this trait. So when there is a generic trait, this is how you can implement this generic trait. So as you can see over here, we are using new with the show, and now we are passing integer. So here we want to make it more generic because we want to define only one functionality. Okay, and it should understand that if it is integer, uh, follow one implementation of this method. If it is a string, follow the another implementation of this method. So instead of show, if it would be add, then if we pass two integer, then we adding, the meaning of addition would be 1 plus 2 would be 3. But if those parameters are a string, then the meaning of the add would become the concatenation. So it is like a generic. So if we call such method with this with integer, it should behave properly according to the string, and if we pass the strings, then it should behave according to the parameters we have passed the string. So for integer it should behave accordingly, for string as well it should behave accordingly. That is what we wanted to achieve with the Scala generic. So we are dealing, what we are doing, we are trying to implement the Scala generic using trait. So by using new keyword, we can create an object of this trait. Okay, but we are actually providing the implementation. So if we don't provide the implementation, we are not supposed to create the object of this trait because we have not defined this method yet. So as you can see, we are creating an object, but we are also defining it, giving the definition to the show method. So show method definition, what we are doing, instead of t, what we are passing is integer in this definition. Okay, because we can implement it with different data types. So here we are implementing it with integer. It is returning string as it is. And what is string? It is making a string from the input you are passing. So as an integer you are passing, let's say 10. So it would replace this int value with the value you are going to pass as an integer. So this is one object of this trait. Okay, this trait, and in this trait the definition of show is this. It is according to the integer value. If it would be according to the string value, then the definition of show would be different. So here, if show would be integer, it would come here. If the if we pass a string, it would come here. So we are creating another object. Again, we are creating another object of trait, but we have to provide the definition or the implementation of this show method. This time we are using string. Okay, earlier we have used integer, so now we are using string instead of t. So this would also become a string. As you can see here, we are passing it string. This is the value we will pass during the call of this show method. It would return a string, and it would return this by replacing the string value you are going to pass. Although the code is almost similar, okay, but here the expected data type is a string, and here the expected data type is integer. That is the difference. So we have different objects for different types of show methods. So if we want to call integer for show method, then we will call this object and we will call this method. So as you can see, integer, it would work on integer. So the name of the method is also same for both the objects, but the objects are different. If you want to deal with integer, then call this int can show dot show method. Okay, if you want to deal with the string, then call this, use this method and call the same method with string. Okay, so in Java generic, this is how you can use the type of the class. So this is actually, you are making the class. This show is the trait is also a kind of class which allow you not to define your method if required. Okay, so during the implementation of that class, we are creating the object of that class. Okay, so during the implementation of the class, we can define the type. That is the meaning of type classes. So during the implementation of the class or the definition or the function or the method, we can choose the type of the class. This is the actual meaning of type classes. So during the implementation of a class, we can choose the type of that class, which is also will be affecting the definition of your method. Okay, so in this implementation we are choosing the type of a class as a string. Here we are choosing the type of the class as an integer, which is later on affecting the definition of the undeclared method in the braid. So this is how we handled uh, we can handle the Scala generic. Okay, this is one way that we can handle the Scala generic. Let me first run it. Okay, this is type classes Scala 1. If I simply run this code, okay, so it would print int value 10 because it is replaced over here by 10. And for main string, because we are passing main string, so this value will be replaced by the main string. So I hope this is clear. By for implementing Scala generic, we have to use type of the class during the implementation of the class. This is one way, but I I I think you can notice one thing over here, that if we are passing integer in show method and if we are passing string in show method, then the class should be able to decide, you know, that okay, go for integer definition, go for a string definition. Then why we need to create two objects? So Scala would also provide a solution for that. Scala would tell you that okay, if you can make implicit objects, then you don't need to create two objects for the same function name. You can create the implicit object. In that case, you can use the same object to call the same method. Not the same method, but the name of the method could be same, but for different values it would behave differently. For integer it would follow the integer definition. For the string it would follow the string definition. But we don't need to create different objects, because we know we are passing different values. So method should be able to decide that okay, it is integer, so let's go for that definition. So Scala provides you a solution. By using implicit object, we can achieve this. We can solve this issue as well. So let me move on to that example. We are using the summable. As you can see, we have used show over here as a trait. Here we are using the summable. Everything else is the same. We are passing t as a generic, and then we have a method as a sum element, which is actually accepting a list as an input, and it is returning that particular type you are passing. So the return type of this function would become whatever the type you would decide during the implementation of this particular class. So by using this implicit object, I told you that we don't need to create different objects. Okay, by this, if the input is integer, your method should be able to decide which definition to follow. So by using implicit object, we can achieve it. So by simply adding implicit object before the implementation of a class, which is actually extending this trait summable. Okay, so for int summable, okay, int summable, we have one another object which is int summable, which is actually extending your summable for int. Okay, so this generic is would work for int. Okay, and in that int we would provide the definition of some element, which is actually for the integer we would accept an integer list, and it would simply return the sum of all the numbers in the list. This is what it is doing, right? Again, we would create another implicit object named string summable, which is again extending the same generic. Okay, this time it would pass a string in this type. Okay, that is what we have discussed. During the implementation, we can choose the type of generics. Okay, in this we are defining or implementing this method. This time we would expect as a parameter a string. Okay, so list of a string would come as a parameter over here, and in return it is returning a string. But what is string? It would add up all the string or concatenate all the string by using make string. We are not, if we provide this, it would concatenate by comma, but we are not providing anything, so it would add all the strings all together. So if somehow this definition will be followed, then the sum of the element will be returned. If this definition will be followed, then concatenation of the string would be returned. A string would be returned and the integer would be returned. But, but I told you that only one object would be enough to call this show element. If the list we are passing is integer, it will call this. If the list we are passing is string, then list of a string, then this method will be called. So I'll create another function which is also a generic function. As you can see, process my list is the generic type T, which is accepting, it is type T, but it is expecting one list as an input, and another parameter of this definition is the implicit objects we have created. I'll tell you what is the meaning of both of these parameters, but first let's understand what is inside this function. So this function would also return the type we are expecting. So if it is a string, it would return a string. If it is integer, it would return integer. And inside this definition, we have the summable. Summable is implicit object. Okay, as you can see, summable is implicit object of what? Summable trait or summable class. So summable trait we have mentioned over here as a generic trait or a class. Okay, it is a basic class, as you can see. So this summable is the implicit object of this summable trait of a generic class. So if, as you can see, with this summable, we can call this sum element method over here, as you can see, for different list. Okay, list is, again, it is generic. We can choose either the string list or the integer list during the call of this method. So during the call of this method, we can pass any of the string. As you can see over here, process my list, we are passing integer list, and we are passing over here the string list. Okay, it should work fine because it is taking the Scala generic type over here. Okay, but this time it is also taking an extra parameter, which is actually the implicit object or implicit superclass of all the implicit objects. As you can see, for this summable generic trait, we have two subclasses or two sub objects, int summable and string summable. But we don't need to use these by ourselves because the compiler would do this for us, because that's why these are the implicit objects. The compiler would do it for us. We don't need to do it. So if we simply call this process my list for integer, okay, it would become the integer list. So this would become integer, list would become 1 2 3, this would become integer. Okay, so in that case, if it would become integer, this int summable will be used by the compiler to call this sum element method, because this definition summable is eventually calling the sum element method. So this summable, this object, will implicitly use int summable object to call this sum element method for integer, because now we have passed integer. So in between summable and sum element, the compiler would implicitly add this object to call this sum element method for integer list. If it is a string, again the flow would be same. This would become string, this would become a string, this would become a string, list would become Scala is cool, three different strings, it would become a string. Now summable is implicit of what? Two sub classes like string and int summable or string summable. So you are calling string list. In that case, the summable this summable would implicitly call strings summable. Later on, this string summable object implicitly will be added somewhere here to call some element method, where we have used this string definition over here. It would return the concatenation of uh, these strings. So if I simply run this code and type classes 2, so first it is returning the value of 1 2 3. It is adding up, and it is concatenating like this. Okay, if anything else we pass except a string and integer, then it would throw an compilation error. As you can see, it is saying that okay, you are passing a list of booleans, but we don't have any such implicit objects. So as you can see, it is throwing some error. So we cannot pass anything which we have not provided any implicit definition for the implicit objects. Okay, so this is how Scala would handle. As you can see, we have used only one object name. Okay, as you can see, we have used only one function but different list. Okay, with different list we are using one function, and later on the implicit objects will be added during the call to the appropriate function. This is how Scala would handle this issue. So these are the two major usage of type classes in Scala. One is this. I have added this code in this file here as well, so you may use it for your reference. Okay, um, uh, this theory is exactly what we have discussed in detail, so you may go through this theory as well. Okay, and in the next video session, let me see, we have covered file input output and type classes. Next we will cover case classes. We don't have much theory on this. We have some examples which can be useful in your practicals as well. So let me start with the last video.